Welcome to the last day of class. Oops. I was wondering, yeah. Let's see. Yep. Maybe. You imagine the projector is screen is not down. The regular chalkboard, like we used to do back. Let's get it. These are review problems are also posted on Canvas. The solutions for all the posted on Canvas. Certainly won't get through all of it today. I would, and most of them are focusing on the trigonometry, because that's what we've been doing most recently. Let's see. Well, before we get going, though, a couple things. Let's see. Thing one, homework solutions I have written and will post, except for the very last ones, because people, oh, there's a handout right there if you want to grab it. Except for XY. So I've got the other ones, what? TU, VW written, I just need to post them. XY I will post as soon as it is closed. The grader and I are working on expeditiously grading the rest of the homework assignments. As far as the final goes, my intent is to have a final exam posted for you by Monday so that you can take it anytime between Monday and Wednesday at 11 p.m. So you should plan on making time to take the final. I think there's, you get like, I think I said 2.5 hours to take the final. I feel like that's about what I wrote on the thing. So you should plan on carving out 2.5 hours between Monday and Wednesday to take the final. I think I posted on Canvas that I will be available in math drop-in Monday through Friday. I posted my hours on there. So if you want to come find me to get help with stuff, I'm certainly there and available. Yeah. For the folks on Zoom, today is less than ideal as far as your viewing experience because the projector is not working. So I will try to keep most of my writing to these first two sections of the chalkboard because that's where the camera is pointed. Hopefully you can see all right. If you need any clarification on anything, don't hesitate to ask. Are there any questions before we get going, before I start using some chalk? My favorite. It is not my favorite. My hands are already usually very dry. The chalk really extra dries them out. At least we're in California though. In Colorado, where Colorado is super. If you've never been to Colorado, it is very, very dry there, and my hands will get really dry and cracky. So I'm happy to be back in California for that reason, among others. But it's definitely a bonus. So let's look at this review. Specifically, I'm going to focus on the trig stuff. However, if you see something on there you would like me to talk about, I am more than happy to do so. For those of you on Zoom, the review I'm talking about, if you want to check it out, is just the one that is the final review that you can find in Canvas. So if you want to go look at it, I'm certainly going to write the problems on the board, but you can't really see the handout without going and looking on Canvas. So if you want to look on Canvas, you certainly can follow along. I'm just kind of working through the Pre16 final review problems. Yeah, so let's start at the very beginning. You guys can see, let me close this. All right, so the other thing I was going to say is you can expect your final exam to be similar in content to the exams that are posted on Canvas. So if you're looking for what to expect, definitely the practice exams and the previous exams that are posted on Canvas are certainly a good indication of what will be on your final exam. There shouldn't be any surprises. I'm not right, try and write like extra tricky problems. It's going to be straightforward, nothing to be like, oh, what's this? So yeah, there might be some hard problems, but definitely nothing out of bounds, right? Like there probably will be like a extra credit problem with the slant asymptote. I think slant asymptotes are hard, so right, there'll probably be something like that, but nothing that we haven't talked about in class. I'm not trying to like write extra tricky problems. Okay, so let's look at the following. Suppose we've got cosine of A equal -2/3. And we're given sine of A is greater than 2. Find the following. I'm going to add an extra question here too. So first of all, what is sine of A? To answer a question like this, we typically need to draw a triangle. There are other ways of doing it, but I think drawing a triangle is the easiest way. So when I think about cosine of an angle, and maybe A is not my favorite choice here, I know that cosine is equal to the adjacent over the hypotenuse. When I draw this triangle, with my angle A, I'm thinking of cosine as being 2/3. I personally like to ignore the negative sign. You don't have to, but I do ignore it kind of until I find the end. So I'm going to find this other side here, which I'm going to call X. And I'm going to find it by using the Pythagorean theorem. And that's almost always how what we're doing to solve these kinds of problems. We have to find the missing side of the triangle, and it's always going to be using the Pythagorean theorem. So we're going to say that 2 squared plus x squared is equal to 3 squared. And we're going to solve for x. So x squared is equal to 9 minus 4. X is equal to the square root of 5. So then we're trying to find sine of A. Sine of A is the opposite over the hypotenuse, which is going to be the square root of 5 over 3. And then in this particular problem, they've already told us that sine is positive, so we know it's positive. Let me ask you though, I'm going to add some extra questions here. What if they ask us to find tangent of A? Well, one way we could do it is just say it's sine over cosine. That would be fine. But if we didn't want to do it, if we were using the triangle, we would say it's opposite over adjacent, which is the square root of 5/2. But is it positive or negative? Well, I'm basing it really on what quadrant the angle is in. So I know that if cosine of A is negative, then we're in quadrant 2 or 3. And if sine of A is positive, we're in quadrant 1 or 2. So what quadrant do we have to be in? We're in quadrant 2. That's the only quadrant where both of the things that are true are true. Great, so if we're in quadrant 2, then tangent is negative. So that's why I'm thinking about always finding the sign of the SIGN sign of my trig function, just basing on what quadrant my angle is in. All right, second question, second part of this question, what's sine of 2A? So for sine of 2A, we have to use the trig identity. The sine of 2A is equal to 2 sine of A times cosine of A. All right, make sure I stay. You guys can see that? All right. It's going to be fun. Let's see. Can we do this more? Sure. It's not great though. Yeah. I'll say words though. So we've already found sine of A and cosine of A. So we're just going to throw those into the formula. 2 times sine of A, which is the square root of 5/3, times cosine of A, which is -2. We should multiply this out. And it helps, you can think of this as 2/1. Multiplying fractions, it's just tops times tops and bottoms times bottoms. So I'm going to get 2 times -2 times the square root of 5, which is -4√5 over 1 times 3 times 3. So there's my sine of 2A. And that's about as far over as I can go and still remain on camera. So there's the end of the line. Can't really go any further than that. Still be on camera. So we'll go back over. All right, so then the next question. And I write some important information, that's fine. What about cosine of 2A? Well, again, I erased, no, yeah, I said, okay. Cosine 2a, I'm gonna use the trig identity for that, which is cosine squared of a minus sine squared of a. So it's the cosine value squared. That's going to be negative 2/3 squared minus the sine value. Squared. We definitely should leave that, right? We don't want to get a decimal approximation here. We should definitely leave sine as √5/3 and not whatever that's approximately to. And then we're just going to multiply this out. So negative 2/3 squared is positive 2 squared over 3 squared, 4/9. And the square root of 5/3 squared is the square root of 5 squared over 3 squared. And 4/9 minus 5/9 is negative 1/9. Cool. So what's next? Tangent, yeah. So this next question, I know that we have never talked about how to find tangent of 2a. There is definitely a double angle formula for tangent of 2a, and in no way should you use it. Because we've already found all we need to find to be able to find tangent of 2a. Tangent of an angle, I'm always thinking of it as just sine of the angle over cosine of the angle. So there is some terrible formula for tangent of 2a. I have never been able to memorize it. It just doesn't want to stick in my head. It's not there. It's fine. I know what sine and cosine are. Sine of 2a is negative 4/5/9. And cosine of 2a is negative 1/9. So tangent of 2a is equal to, let's see, negative 4√5/9 times negative 9/1. The 9's cancel, negative is negative is positive, so I get positive 4√5. That's how I'm finding tangents. Bonus question, which I definitely like to ask. Yeah. So the question I will almost assuredly ask on the exam is, what quadrant is angle 2a? And not just tell me what quadrant, but and justify your reasoning. And the way we justify what quadrant angle is in is by talking about whether sine and cosine are positive or negative. So we know that sine of 2a, which I already did, sine of 2a is negative. That means 2a could be in which two quadrants? All sine is negative in quadrants. Right. So quadrant 3, quadrant 4. And we know that cosine of 2a is also negative. Cosine is negative in quadrants 2 and quadrant 3. So the one that satisfies both is quadrant 3. So that's the angle of that's the quadrant that angle 2a happens to be in, this quadrant 3. So whenever you're asked what quadrant an angle lives in, the idea is that you need to find sine of that angle and cosine of that angle to help you narrow down which quadrant it has to be. And knowing those two pieces of information is always enough. If you know sine and cosine, that's it. You know enough information to fully determine what quadrant your angle is. All right. Don't hesitate to ask questions if you've got them. I'm just going to keep going here. But if you want me to stop and say words about things, I certainly can. All right, number 2. Find the exact value of cosine of 25 pi over 6. Exact value just means not a decimal approximation, right? Like your answer might be square root of 3 over 2, not 0.866 or whatever. 25 pi over 6, we know just looking at this, the reference angle has to be pi over 6. right? It's a sum, it's a pi over 3 or a pi over 6 or a pi over 4. Since my original angle is some multiple of pi over 6, we know our reference angle is pi over 6. We could also draw some stuff there. What quadrant do we live in? Good question. There's so many ways to think about what quadrant you're in. Here, this is a hyperextended angle, right? It's more than one full revolution. I'm thinking of 2 pi as one revolution, and I'm going to multiply that by 6 over 6 to get 12 pi over 6. That's one full. I looks like I've got a little bit more than 2 full revolutions, right? Because if I do that again, if I do 4 pi, that's going to be 24 pi over 6. So that's looking like just a tiny bit more than 2 full revolutions. I'm doing 12 pi over 6, 24 pi over 6, and then 1 pi over 6 more. But really, I'm thinking of this as 24 pi over 6 plus pi over 6. That's how I get this. Either way, our reference angle is pi over 6, like we said, but now we can also see that our angle is in quadrant 1. So we're going to write the cosine of 25 pi over 6 is positive. We're in quadrant 1. All right. What's the value? Is it 1/2? Is it root 2 over 2? Is it root 3 over 2? I'm going to draw a triangle. You don't have to draw the triangle. You can just know the value. Totally valid. But if my angle is pi over 6, opposite 1, hypotenuse is 2, adjacent is root 3. So cosine of pi over 6 is root 3 over 2. So cosine of 25 pi over 6 is positive. You should write that you're finding cosine of 25 pi over 6. Yes, it is the same as cosine of pi over 6. But this is what we're actually finding. All right. Yeah, question.
You just write like cosine equals square root of 3 over 2, would that be half right?
You really, so the thing is, you really should write the angle. Because when you write cosine without an angle, it's like writing, my analogy is, it's like writing a square root without a number under the square root. Right? There's just, I know what you're trying to do, but it doesn't make sense necessarily. So I'll probably be fairly forgiving as far as that goes, but I would really like you all to write cosine of whatever your angle is, because there's less meaning without it. I know it's not a great answer, but it's the truth, right? We definitely should write that. If you forget to, it won't be terribly detrimental. All right. I'm gonna skip the law. Okay, so question 3 here. I feel like I need to change this question. So this question is not a good question, at least, or it's a perfectly fine question if someone's trying to trick you. Because they give you a hint here or a note that is not at all necessary. Nobody needs you to know that 5 pi over 6 is equal to 2 pi over 3 plus pi over 6. To me, what that note is saying is someone's trying to induce you to use the angle sum formula when you don't need to use it at all. 5 pi over 6 is an angle we totally know how to find cosine of. Our reference angle again is what? 12 pi over 6. What quadrant are we in? Quadrant 2. Great. So cosine of pi over 6 was root 3 over 2. Cosine of 5 pi over 6 is going to be negative. Done. On the other hand, I would ask something like, what is cosine of, sure, let's go that way. Let's say 17 pi over 4. Which definitely does require the angle sum formula. Which I will probably write. I will write on the 5. either in the problem or on the front page. Not that you couldn't look it up. But it'll be there so you don't accidentally look it up and write the wrong thing down. So the cosine formula, cosine of A plus B is cosine A times cosine of B minus sine of A times sine of B. Your job for a problem like this really is to find the angles that add up to that angle that we know how to find sine and cosine of. And the trick, in my opinion, for doing it is to write 17 pi over 12 or whatever the angle is as the sum of two angles where the fractions will reduce. That is the key thing. I'm gonna write 17 pi over 12 as, I usually just like to pick the smallest angle I can. So it's not going to be 1 pi over 12 plus 16 pi over 12, because 1 pi over 12 doesn't reduce to having a smaller denominator. So I'm going to try the next thing, which is 2 pi over 12 plus 15 pi over 12. Both of those reduce, plus you. Yeah, they both reduce. That's going to equal pi over 6 plus u again, plus, let's see, 3, so it's going to be 5 pi over 4. It's not the only option though, right? You could also have done 3 pi over 12 plus 14 pi over 12. Or 14 and 13 wouldn't work because 13 pi over 12 doesn't reduce. Yeah, so you want to pick two things that reduce. You want to end up with two angles in radians where one of the denominators is a 4 and one of the denominators is a 6 or a 3. That's always what's going to happen. So then we're going to write cosine of pi over 6 plus 5 pi. And it's going to equal cosine of pi over 6 times cosine of 5 pi over 4 minus 5 pi over 6 times sine of 5 pi over 4. And then we find all the values. So we've already done cosine of pi over 6 twice. It's still root 3 over 2. And knowing that cosine of pi over 6 is root 3 over 2, we also then can deduce that sine of pi over 6 has to be what? What does root 3 over 2? 1/2. Right, when I'm thinking about the angle pi over 6 or pi over 3, one of cosine and sine is 1 over 2, and the other one is root 3 over 2. Those always go together. And then the pi over 4 one is going to be a root 2 over 2. We just have to figure out if it's positive or it's negative. Well, 5 pi over 4 is in quadrant 3. So we know that cosine of 5 pi over 4 is going to be negative, and sine of 5 pi over 4 is also going to be negative. They're both going to be negative root 2 over 2. There is an expectation that we simplify this. It simplifies in the same sort of way every single time. It's always something with a root 6, something with a root 2, all over 4. And they're either positive or negative. So they can both be positive, both be negative, one be positive, one be negative. In this case, we end up getting, write it down here. Root 3 times root 2 is root 6. So we're going to get a negative root 6 all over 4. Minus a minus is plus 1 times root 2 is root 2 all over 4. And we should write this as one fraction. You can either write it as negative root 6 plus root 2 all over 4. Although in my opinion, when one of them is negative and one of them is positive, I usually like to write the positive one first. So I would probably choose to write it as root 2 minus root 6 all over 4. But either way of writing this. They always look like this. So these angle sum problems, angle difference problems, they always turn out this way, where it's plus or minus root 6, plus or minus root 2, all over. Most of them require the angle sum formula, but there's a couple that are a little trickier. Maybe not trickier. Like I could ask you what's sine of pi over 12. And it's really, although you could, it's not super easy for me to find angles that add up to that. But there are definitely angles that subtract to that. Like, you write this as 4 pi over 12 minus 3 pi over 12. For example. That's how I would approach that. Or you could do 3 pi over 12 minus 2 pi over 12. That would also work just fine. Or if you really, really wanted to, you could change it to degrees. Right? Pi over 12 is equal to 15 degrees. And then you can say the sine of 15 degrees is equal to sine of 60 degrees minus 45 degrees. You wanted to approach it valid. It's totally valid. I think it's good to work in radians, but I also understand changing things to degrees because sometimes our brains just see degrees better. I wasn't going to finish that problem. I was just going to say that I could ask something like that. Question.
So would it be fine if we would use either both radians or degrees, or do you want us to use one or the other?
You can use. I wouldn't really recommend using both in a single problem. Yeah. Like if you're gonna do this problem, you should either do it in radians or in degrees. You shouldn't like go back and forth. Really, I would think you can just be using
Either or.
Yeah, you can do either or. Trying to think of a situation where you would have to use one or the other. Can't really think of a situation where you require to use one or the other. I will say, I find it somewhat more challenging to do these types of problems for larger angles in degrees. Like for example, if I asked you to find sine of, I don't know, right here, sure, 335 degrees. Is that what I'm looking for, really? Yeah, that looks fine. For me, I find it more difficult. Is that really what I want? Well, no, I want 345 degrees. Sorry. I don't know. To me, it's harder to see how to break this up personally. That's just me though, maybe. Maybe this is totally easy for you. You could probably break this up as sine of 300 degrees plus 45 degrees. That should work, I think. I think that's an angle we know how to find sine and cosine of, because I'm pretty sure the reference angle for 300 degrees is what? 60 degrees. Right, because it's how far we are from 360 degrees in this case. So yeah, you could totally do using degrees as well. I just tend to do it using radians. Okay. That said, if you're going to change from degrees to radians or radians to degrees, you should show the work, right? So if I give you, something like sine of pi over 12, or sine of, let's make it more interesting, let's say sine of 5 pi over 12, and you decide you really want to do it in degrees, you should show me 5 pi over 12 times 180 degrees over pi, cancel the pi's. 5 times 180 is 900. I probably should have done the division first. Oh, well, too late. 900 divided by 12 is, I don't know. That dude, let's see, 300 over 4. That's going to be 75 degrees. Should show some amount of work that you're converting it. Okay. The next one. People on Zoom, let me know if you need me to do anything differently. Yeah. Fine. Sure. So for beta equals to 7 pi over 6, all the trig terms. So pi over 6 again. There's not a lot of angles that we can use really. And my reference angle is certainly pi over 6. And my quadrant is quadrant 3. A little bit bigger than pi. So sine of 7 pi over 6. Whatever way you can get there. If you want to draw the triangle, totally fine. Pi over 6, angle for opposite side 1, opposite side 3. So sine of 7 pi over 6 is going to be negative 1/2. So sine of 7 pi over 6 and for quadrant 3 is going to be, maybe I would also throw up a little, in case you've forgotten, quadrant 3 tangent is positive. Cosine 7 pi over 6 is going to be negative root 3 over 2. And tangent to 7 pi over 6 is going to be opposite over adjacent, so positive 1 over root 3. And it's okay if you don't rationalize this, but it's good to rationalize it by multiplying by root 3 over 3. To get root 3 over 3. And then the reciprocal. So secant to 7 pi over 6 is the reciprocal sign, which is going to be negative 2. Secant to 7 pi over 6 which is the reciprocal of cosine, is going to be -2 over √3, which rationalizes as, right, exactly, -2 √3. Just multiply by √3 over √3. And then finally, cotangent to 7 pi over 6. Now, when you find cotangent or reciprocal of one you had to rationalize, you want to typically find the reciprocal of the thing before you rationalize it, because it's easier. So find the reciprocal of 1 over √3, which is √3 over 1. For angles that are not in quadrant 1, if you're finding all 6 trig functions, 4 of them should be negative and 2 of them should be positive. All right, you've got the one positive one and reciprocal also being positive, and you've got the 2 negative ones and their reciprocals also being negative. Unless, of course, it's a quadrantal angle. Like what's on here? What is on here? Sine of, or for an angle of 3 pi over 2. So our unit circle, 4 corners of the unit circle. You don't have to label every single corner if you already know which part you're looking at. But I know I'm right here where that's my angle is 3 pi over 2. So if I'm going to write things out, it's kind of unfortunate. I feel like the standard way of writing out the 6 trig functions really is sine, cosine, tangent. Like it's just the standard. I'm not sure why it's the standard. I can have a few guesses. Maybe because sine divided by cosine is equal to tangent, and that's kind of nice to see. But it's unfortunate because when you're finding sine and cosine, sine is the second coordinate and cosine is the first coordinate. So it can feel kind of out of order when you're writing it that way. That said, we're going to do it that way. So sine of 3 pi over 2 is equal to -1. Cosine of 3 pi over 2 is equal to 0. I should point out, there's not a lot of work to be shown for a problem like this. The work you can show really is drawing the little unit circle and pointing out the point you're at, and that's kind of it. For tangent of 3 pi over 2, I would probably encourage you to say, even though it's undefined, you might want to write out that you know it's that over that, and then like, oh yeah, that's undefined. Divided by 0. You can say it's undefined or does not exist, whatever abbreviation you prefer. And then the reciprocals. Cosecant of 3 pi over 2 is 1 divided by -1, is -1. And secant of 3 pi over 2 is not really 1 divided by 0, it's undefined. Does not exist. And finally, cotangent of 3 pi over 2 is 0 divided by -1, which is 0. 0 divided by not 0 is 0. Something divided by 0 is undefined. You'll see a lot more of next quarter when you take calculus. A lot of dividing by 0 when you're trying to find the definition of a derivative. That's for next quarter. Oh, also, sorry, real quick, just a reminder, I believe the math placement test is available to take currently, right? Am I correct in saying that? Most of you should have gotten an email about it. Is that also correct? Like some of you haven't. Okay, so I feel like the math department might not be totally on top of it this quarter, so it should come soon. I'll talk to my colleague about it because she knows more about what's going on. So if you're concerned about the math about knowing when or where to take the math placement test, shoot me an email and I will try to figure out things for you because I'm curious as well and I would like to help assuage those fears. So definitely you have a chance. I believe you can take it starting today up until like next week sometime, and then also again the first week of next quarter. So I would probably recommend taking it after you've taken this final. Maybe not like right after, but like not too long after, so that you have still the math fresh in your mind. And also the last day, I don't actually know the last day you can take it, so I will tell you that. But I'll try to post something on Canvas for you all in case you need more information. I don't want you to miss out on having 2 shots at taking the math list. Okay, sorry, I just came into my head all of a sudden, so I thought but yeah, let me write myself. Oh no, I'll remember. I'll look into that after class. Next problem. find sine of 22, 2, yeah, so pi over 3. All right. Another angle, another reference angle. Reference angle here has got to be pi over 3. I definitely am not going to be asking you to find sine or cosine of angles we don't know how to deal with. Any angle I'm asking you to find sine, cosine, tangent of is going to be an angle that we know the reference angle for. I'm not going to ask you to find sine of 10 degrees or some other strange number that we're not familiar with. So if you see finding trig functions of an angle, you should think, oh, I know how to do it. Reference angle is pi over 3. What quadrant are we in? And what quadrant are we in? We've got a lot of revolutions here. So typically when I'm trying to think about what quadrant I'm in, I'm trying to find how many multiples of pi we've got. So I'm thinking of 22 pi over 3. You could actually do the division, like 22 divided by 3. 3 goes into 22, 7 times. And 1 left over. So I can think of this as 7 pi plus, I've got 1 pi over 3 left over. I'm not writing this because I want to use the angle sum formula. I'm writing this to help me figure out where the angle lives. So 7 pi is not 7 full revolutions. It's 7 half revolutions. So 7 pi is really 2 pi, 4 pi, 6 pi, 7 pi. And we want pi over 3 more than that. So there's our 7 pi over 3. Occasionally on the test, I do ask you to locate the angle. So like I might ask you to draw something like this so you can show me where the angle lives. But we're definitely for sure in quadrant 3. Reference angle is pi over 3. We're in quadrant 3. And then sine of this angle is going to be, let's see, sine of pi over 3 is root 3 over 2. The sine of 7 pi over 3 is negative 3. That's kind of it. There's not, again, for most of these like find sine or cosine or tangent of an angle problems, there's not a lot of work to be shown. The work you can show is how to find the reference or what the reference angle is, what the quadrant is, and then what the value is. You don't need to draw a triangle to convince me you know what sine of pi over 3 is, although if you want to draw the triangle, you certainly can. You definitely don't need to write out the whole unit circle for me if you happen to be a unit circle fan. You can just say you know what these values are. All right. Chalk. Lovely, lovely chalk. Okay, so, oh yeah, some graphing. Let's graph one period of 2 sine 2x plus 4. So there's a few things to consider when graphing a trig function. We have an amplitude of 2. And we have a vertical shift of up 4. Before I even do anything else, I know things are looking like this. Going up 2, so up 4, apologies. My new middle is y equals 4. And then I'm going to be going an amplitude of 2. So 2 above and 2 below. Those are the only y values I'm really concerned about. How far up or down I've gone, and then the amplitude above that and the amplitude below that. Those are the only things that really, really matter as far as the y values. And then we need to find 5 important x points, or x values, whatever you want, I don't know, x values of x. So first we start off by first we start by what's the period? The period is 2 pi divided by 2. And I should be specific. It is this 2 that we're dividing by, not that 2. So it's the coefficient of x, which is pi. And then 1/4 of our period is pi divided by 4. Is there a phase shift? No, there is not. There's no horizontal shift because inside the sine function, there's no subtraction or addition. There's no phase shift. Or no horizontal shift, whatever you want to call it. So our first x value is just starting where? We haven't shifted left to right, we're starting at 0. And then we're going to find all the other 4 important x values just by adding a quarter of our period 4 times. So my next important x value is just 0 plus pi over 4. And my next important x value is pi over 4 plus another pi over 4. You don't need to write out if you're adding pi over 4 every time. You can totally just write down what the values are. My next value is 2 pi over 4 plus pi over 4, which is 3 pi over 4. And my last value is 3 pi over 4 plus pi over 4, which is 4 pi over 4, aka pi. So those are the values that are going on my x-axis. Your graph doesn't need to be to scale. It can be. I know that pi is, I'm thinking like pi over 4 is about 3/4. I don't want to make, right, if I do this to scale, 3/4 is like about that much. So my point would be like that. This is not the graph I want to draw. Give yourself axes that are reasonable to draw the thing on, even if it's not the scale. Totally fine. What I'm going to do instead is just, I'm going to pick a length. Sure, that can be pi over 4. And then I'm just going to do that amount each time. That's a nice much, huh? There's my other important exponents. All right, and then you can either remember what sine looks like, or if you want, you can draw yourself a little unit circle. Remember that sine starts at 0, the y value, and then 1, and then 0, and then -1, and then 0. So, but we're not starting at 0 really, we're starting at our new 0, which is the middle. And then we're going up 2 because we're multiplying how much we're going up by 2. And then back to the middle, down to the bottom, which is 2, back to the middle. For the usual sine shape. Maybe. Questions about any of what I said there? What's happening? The other thing one other thing to be aware of is there was a negative sign in front of the whole function, it would flip the function over and it would flip the curve. All right, let's not graph tangent, because I'll be honest, I'm not going to ask you to graph. Let's look at 14, which is finding some solutions. I want to solve 1 minus cosine of x equal to cosine of x for x between 0 and 2 pi. I suppose technically your answers here should be in radians, since I specifically said that x is between 0 and 2 pi. You could probably still write them in radians. So if I'm solving this, whenever you're solving trig functions or trig equations like this, you want to isolate the trig and the metric function. So I'm going to rewrite this as 1 equal to 2 cosine x, because I'm adding cosine x to both sides. And then I want to divide both sides by 2. And then I want to find the reference angle and the quadrants. Let's find the quadrants first. Cosine is going to be positive. And I made an announcement on Canvas because someone pointed out to me just 0. I did make a mistake in class the other day where I said when we were solving, well, we'll finish this problem first, and then we'll talk about the mistake about it. So I'm solving cosine x equal to 1/2. Quadrants our answer should live in are quadrant 1 or quadrant 4. And if we're saying cosine is equal to 1/2, our reference angle is pi over. It's cosine of pi over 3 equals 1/2. Excuse me. So then our actual angles are going to be pi over 3, because that's the reference angle is the angle in quadrant 1. And then the other angle in quadrant 4 was going to be, let's see, move all the way almost to 2 pi, but I'm going to be short by pi over 3. It's going to be 2 pi minus pi over 3. Which we should simplify as 5 pi over 3. Those are my just so everyone knows, or I can clarify, the other day when in class we were solving, I believe we were solving cosine of x equal to negative root 2 over 2. And we got the correct reference angle to be pi over 4. And then I mistakenly said that our answers were in quadrants. I guess in quadrant 3 and quadrant 4. But it should have been really in quadrant 2 and quadrant 3. But I was being not careful and I didn't write this out. So if you're ever not sure, write out your little all student take calculus and maybe you label the quadrants to be extra careful. Like, oh, cosine is going to be negative. Yeah, I need to be in quadrant 2 or quadrant. So our answer should have been here, x equal to 3 pi over 4 in quadrant 2 and 5 pi over 4. And then there was another one here. Well, we just did one like that. Let's do something more interesting. Do a different trig equation instead. Let's say we want to solve sine squared x plus sine of x. So if you're ever trying to solve a trigonometric equation, and you've got powers of your trig function that are higher than 1, probably gonna have to do some sort of factoring. Here the factoring is not terrible. From sine squared and sine, I can factor out a sine. I've really got sine of x times sine of x plus 1 equal to 0. So then I'm going to set, just like I would solve a regular equation equal to 0, I'm going to set each factor equal to 0. So we're either going to find where sine of x equals 0 or where sine of x plus 1 equals 0. AKA where sine of x equals negative 1. And there's a reason I don't like this question, but it's fine. Talk about it in a second. So sine of x equals negative 1. These are definitely quadrantal angles. 0, 1, negative 1, 0. If you just want to like write this on your exam somewhere, so you don't have to write it like 5 times, or you can just write it down. You don't need to write it over and over. You like refer to the thing I drew on this other page or something like that, whatever you want. My angles are 0, pi over 2, pi over 2, pi. So, what angle gives me sine of x equal to negative 1? Okay, and that's the only one in 0 to 2 pi. What angles give me sine of x equal to 0? Well, what's the smallest one? 0. What's the next one? That's it. 2 pi is not an answer because the way we stated the domain for our answers, we shouldn't include 2 pi. If you accidentally included 2 pi, not. But usually we don't include both 0 and 2 pi because they're coterminal. They end at the same place. So usually it's one or the other, not both. Although some classes in the future don't adhere to that rule. Let's look at this last. Well, not last, but let's look at one more trig thing, and then we'll be out of time. Yeah, let's look at simplifying this to a single trig function. Oh, it's terrible. Cube root, yeah, it is. Cube root of tangent of x plus cotangent of x all over secant of x minus cosine of x. And I'll be frank, I don't really want to write the cube root of all this stuff like 5 times. That seems really terrible. So what I would probably do is just deal with the inside and then go back over there and take the cube root at the very end. Here's what I mean. I'm just gonna write tangent of x plus cotangent of x all over secant of x minus cosine of x. Wow. Okay. And then typically we want to change everything to be in terms of sines and cosines. That is almost always your go-to first step. So we're going to write tangent as sine x over cosine x, cotangent as cosine x over sine x, secant as 1 over cosine x, and cosine is just cosine. But since we know we're going to need common denominators, we might as well say that cosine is cosine x times cosine x over cosine x. This would maybe cut down on one of the steps we have to do. All right, so on top, we need common denominator as well. So we're going to multiply this by cosine x with cosine x, and this by sine x over sine x. Cool. So let's see. On top, I have sine times sine, sine squared x, and cosine times cosine, which is cosine squared x, all over their common denominator, which is sine x times cosine x. Divided by, here I have 1 minus cosine squared x, all over cosine x. At this point, you always kind of have a choice. You could either, you gotta kind of do both these ones. I would probably use trig identities, meaning the Pythagorean identities. We know that sine squared plus cosine squared is equal to 1. And 1 minus cosine squared is equal to sine squared for the same sort of reason. So I would write this as 1 over sine x cosine x over sine squared x over cosine x. And then I would flip and multiply. So I would write this as 1 over sine x cosine x times cosine x over sine squared x. Cosines cancel. You've got 1 over what? Sine cubed, which we should really actually write as cosecant cubed. And then I would go back over, so I've done all this work on the side kind of. I would then go back over here and say, okay, this is the cube root of cosecant cubed x, which is just cosecant. But I would certainly be fine with you not writing the cube root of all that stuff every single time and just at the end be like, okay, the inside is equal to that. Then the original thing is equal to the cube root of that, which is then just cosecant. All right, that is all we have time for. Solutions to this are posted on Canvas. If you want to look at that, there's also practice exams posted on Canvas and the solutions as well. It's been fun having you all. As far as next quarter is concerned, if you're looking for help with whatever math class you're taking, I'm around. I'm not teaching any of the co-classes you might take, but that doesn't mean you can't come get help from me in math drop-in or making an individual appointment or whatever. So don't be strangers. Come get help if you need it. As far as this quarter goes, the final will be posted sometime on Monday, hopefully sooner than later. And yeah, usual kind of deal. There shouldn't be any surprises really. And then I'll take a look into the math placement test stuff. Office hours next week are not as typical. So there's actually more office hours next week. If you look, I posted an announcement on Canvas that shows when I am in office hours and also a link to when everyone's office hours are. But all office hours next week are in math drop-in in the library. So that's where you can find me or Grant or Sarah or Jen or whoever you're looking for, or the student tutor as well. You're welcome. Good luck on all of your finals. Oh yeah, and fill out the attendance form. Got it.
Spam folder. It was in the spam folder.
Oh yeah. Yeah. Yes, but just in cats.
Oh, over
Yeah. I don't, but because of Friday, the only office hour I have is.
Yes, I know.
Well,
Thank you.
you're welcome. Yeah, you too. Have a nice, longer than usual break for UC Davis.
Oh, yeah.
Yep, it's kind of as long as it ever gets. So enjoy it this year because next year will probably be shorter.
I have a few questions.
Sure.